All right, welcome to the actual first official physical meeting of the CTF interest group. Today we'll be going over a challenge from Pwnable.kr. It's a Korean mock capture the flag competition. They have lots of interesting challenges. It's kind of video game themed, but all of the challenges I don't think have anything really to do with video games. The one we'll be looking at today is BOF. The blurb for it is, Nana told me that buffer overflow is one of the most common software vulnerabilities. Is that true? Gives you 2 download links for the executable and C file, as well as the NC link to actually try the challenge. So let's have a quick look. Since this is a challenge that's actually really nice enough to give us the actual code, let's have a quick look at it. This is not what I wanted, though. All right, let's try. There we go. Now we can close this. So let's have a quick look at the C code that they give us.
Can you see that okay?
Okay. So what we have here is we have a main method and a external function. The main method simply calls the function, passes in a hexadecimal value that spells out dead beef, and then returns 0. The function, which is where we'll be looking at most of our code, is first initializing a character buffer or character array, prints out a string that says overflow me, then takes the user input, then checks if the key that was passed to it matches Cafe Babe. If it does, you get immediate access to the shell. Otherwise, it says nah, and then leaves, and then ends the function. So this is actually very nice that they gave you the C code. It helps you maybe understand a little bit more of what's going on. But what we're going to be looking at today, for the most part, is actually looking at the decompiled code. I generally like avoiding specific tools and teaching specific tools, but in this case we're kind of going to have to. So we're going to use a tool that's actually readily available for most people, especially if you use Linux. It's called GDB, which is GNU Debugger, and we're going to look at our binary that they gave us. So what this allows us to do is we can disassemble the code we're looking at. So let's start with disassemble the main function. So this is the assembly code of the main function that we're looking at. Here we see that so this, I do expect you to at least understand assembly. If you don't understand assembly, that's fine. I will link later on in the video description for this, or if you ask me specifically, a really nice introduction to understanding assembly in context of what we're doing here today. So what we're actually going to be doing today is based on how this method is, and this is more of an experience thing, and because they give us a massive hint at the beginning, we're doing a buffer overflow attack. So what we're going to be doing is using our user input to overflow the buffer and then overwrite the key that we passed in, which was dead beef, so that it matches Cafe Babe, and that way when it gets to this check, we've overwritten it and we actually get access to that. So how do we do that? Well, the first step is to look at the disassembly. The disassembly for main isn't too interesting. Basically it starts up the main method and then moves the value for dead beef into the pointer for the function, and then calls the function, and that's basically it. After that, it returns 0 and nothing interesting. So let's look at the disassembly for function. Okay, so this is a little bit more interesting. If we look here, we can get a feel for what's going on here. We know that we have a few function calls before. So if we look at our code that we were given, we know that we definitely call a printf, we call a gets, and then we call either a system or a printf. So here we can assume our first call is probably going to be that printf. Our second call is probably going to be that gets, and then we should have a comparative statement, which is right here. So, and then from there we have a jump if not equal to, and this call is obviously to the system, and then also we have probably a call here that's one of these is either the system and the other one's probably another printf. Since we actually know this one is probably printf, we can probably compare it and find out. But anyway, the most important part, the most part we're interested in here is this compare, because that's the part where we want things to kind of change. So to do that, we can actually start up our debugger. So right now we're just viewing this assembly. We can actually say start, and this will spin up the actual program. We can then again disassemble our function. And now it's actually been kind enough to find out what each one of these functions is. So this one is saying, okay, this is the puts, this is the gets, this is our system, this is our other puts. So it's giving us a little bit more information. I will point out that there are tools out there, such as Radar 2, and there's even a few Windows tools that are available that will probably give you even more information. This is just the most basic tool that's already available. So now the point we're interested in is this part right here, our compare. So we're gonna set a breakpoint for this, and then continue. So now we're given that overflow me prompt, so we can give it pretty much anything. In this case, I'm just gonna say look for me. Okay, and then we can again disassemble function, and now we have a little pointer for where we are in our execution. So now what we want to do is we want to find out, since we're trying to overflow our buffer and then overwrite it. So at this part, it's really important to understand how a stack works, how stack works in terms of assembly. So basically, when a function is executed, its arguments are pushed into the stack in reverse order. So if I have a function that calls integer A, integer B, and integer C, C is going to push it onto the stack first, then B, then A. And then on top, then the function itself gets called, and then everything within the function gets called after that. So in this case, what's happening is we have our key here. So when this gets called, dead beef, the integer, the space for key gets pushed into the stack with dead beef, and then from there we're calling this function itself, and then we call the character array for overflow me. So what we need to do is we need to find where the character array starts and how much space between the start of the character array and the start of our integer, so we know how much we need to overflow in order to start overwriting what we want to overwrite. So let's do that real quick. So how do we know where to look? So basically, the first step is, the nice thing about this compare is it's telling us, okay, we're comparing Cafe Babe to the address EBP plus 8. So if we look at our code, we can see this compare is over here, and that key is what's being compared. So what we can do is we can, and again, this is, don't worry too much about the specific syntax of this. This basically just means examine the hexadecimal words at EBP plus 8. Oh, did I do that? Oh, I need to specify it's a register. Okay, so there we go. We got our address. That address is, it says dead beef is at the address FFFD2E0. So we're good to go. That's a good start. The next step is to find out where our buffer, our character array starts. And that's a little bit more tricky. But the good news is that if we look over here at our call, for gets, before the call, we are moving in. We move the address at EBP O2 minus OX2C into EAX, and then we move EAX into ESP, and then we call. So most likely, this is what we're looking for. EBP stands for the base pointer, which means the frame of reference for this function. So if we give this a shot, we're modifying this a little bit because we don't actually care about hexadecimal, we care about the string this time. So we're saying examine a string at this address, and here we go. We have the look for me that we entered in. So this tells us that, hey, this is where my my array is, my character array. So the next step is for us to find the difference between here and here. We could do this manually, or we could just use Linux, because Linux gives us tools for that. I believe this is from before that I have, but I think it should be the same. D2E0 and D2AC, D2E0 and D2AC, perfect. So what this does is it just echoes those and passes it into BC, which is a calculator. Comes with Linux, so I'm just going to run that. And it tells us, hey, there's a difference of 52 characters between where your buffer starts, where your character array starts, and where the integer key starts. So what we need to do, and it is good to note that each character is 1 byte. Overflow me has a max size of 32 bytes. So we are overflowing that character array and then continuing on past that. So we're probably overwriting some what would be maybe important values, except that we're not really too worried about that. All we care about, because if we were worried about maybe going back into main, this might have been a problem. But since we're overwriting everything, and then immediately as soon as we get through that overwrite, we're going into our bin/bash, it's not a problem in this case. So we don't have to be too worried about that. So what we're going to do is we're going to, since again every character is 1 byte, and we have a 52 byte difference, we're going to put 52 bytes into our character array, which will overflow it. And then in addition to those 52 bytes, we're going to put in Cafe Babe into our input as well. So that comes out with an overflow and then overwrites the last few the bytes for our key value. So here there needs to be a small distinction. This is very dependent on whether your program is compiled in big endian or little endian. The endianness of a program specifies in what order the data is put in. In this case, it's a little endian. It's usually going to be little endian if you're using Linux. But you can, if you care about checking, there are some tools to do it. One such tool is RABin2. You can go BOF, or you say -G, BOF, and this prints out the information about it. This is the part you care about. It basically tells you here what kind of machine it was compiled on, what kind of operating system it's running on, and if you look here, yeah, it specifies the endianness of the program. So it's little endian in this case. So what that means is I have a solution written up. So you can do this with Python. In this case, I'm going to, I wonder if I have one saved from before. Guess not. So I'm just going to use the solution I have written up. It will do basically the same thing. You can do this in a one-liner as well. So the solution I have in Python, it's using the Pwn library. All this does is just gives me a nice handy interface for connecting to specific things. I'm going to go ahead and connect to the server that they gave us in our in the prompt. If we look here at the prompt, they say it's running at Pwnable.kr 9000. So I'm just going to connect to that. I'm going to then create my overflow string. So here I say, okay, I want you to it's going to have A repeated 52 times, and then the end of it, I have Cafe Babe. Since it's little endian, the information goes in in the reverse order. So BE first, BA, FE, CA, since each one of those is 1 byte. Because those are hexadecimals. These are not strings, these are hexadecimal values. So it's 1 byte, 2 byte, 3 byte, 4 byte. Okay, so then I'm going to send that line to Pwnable.kr. At the end of that, I'm going to, since that gives me access to the bash, I'm going to say, hey, I want you to run the command cat flag. For those of you who don't know, cat just prints out whatever the file is, whatever's inside the file. So it's going to print out. And then I'm going to ask it to print out the result from that. So let's give that a quick run. Okay, and so this is the flag I get. Daddy, I just pawned a buffer. So what we've done is successfully overwrite the key value so that it allows us to change the input that was given so that we can get access to that bash. If anyone's interested in what it looks like when you don't do this successfully, again, that's what you can expect if things aren't going to work. Any questions? I know that's a lot of information. I was hoping we'd have a little bit more people so we could have like a bit more of a discussion, because this is assembly and it is difficult for most people to kind of wrap their head around, especially if this is the first time they're seeing it. And even for most people who've taken this assembly class at GSU, I think we still have trouble with that. It's not a simple topic.
Like maybe the only question I would have is about the Python. So when it says A times 52, it's referring to the A in the BOF.c file.
No,
not.
It's referring. This
Oh,
is just.
A,
This
it's
is
the letter
literally
A,
the letter A. I can
Okay,
replace this with
52.
anything. It's just I told it to replace it. Just insert this 52 times,
Yeah.
and then that. So that gets us to the point where we're at the start of our key, and we can start putting in the values we actually want into our key.
Okay.
So yeah,
And that's hexadecimal. Why?
this is hexadecimal because the check they have for it is they're checking hexadecimal values. So if we look at BOF.c, they care about is the hexadecimal value. It's not a
Okay.
string.
All right.
Like same thing. The input here is a hexadecimal value. They have it so that it's human readable, and you can be like, oh, that's dead beef, but that's actually a hexadecimal value.
Okay.
So what we're doing here is we're going in here and overwriting this so that it matches this, so we can get into bin/sh.
Okay. Yeah, I don't think I have any more questions.
All right, cool. So I think that's it. As a quick side note, for anyone watching this later on, if you do have any questions, feel free to just ask in the Slack channel or get in contact with me directly. I'll be happy to answer any questions you may have. And, thank you for listening.